So earlier we learned what MPLS is and how MPLS makes the label switching and how label switching makes the routing faster. Today, that how we are going to go deep into it. How that label switching really used, how it is really used, how it is used to make our routing faster. One reason we saw earlier is we no need to read the entire layer 3 header of every incoming packet. Instead, we read only 32-bit MPLS header, which has got 20-bit reservation for label, 3-bit reservation for class of service, 1 bit for bottom of a stack, and 8-bit for time to leave. We have seen this earlier. Today we are going to see again how this label can make my routing faster. Let's take similar topology as we saw in the previous class 1. Let me try to find a picture from Google. Let's begin. Let me start from this picture. You see, in order to reach from a source to a destination, the path need to be taken is via router 1, 2, 3, 4, 5, and 6 and 7. That's the path. This shows that the packet needs to go like this. Layer 0, layer 1, layer 2. Alright. Next is very nice picture. This one is very nice picture. This actually explains the bottom of a stack. There are VPN inside VPNs. That is why stack. You see, in order to go from router 1, while it goes from router 1 to router 2, the label given by router 2 is used. You see, it enters as an IP packet. The packet enters as an IP packet. And this router 1 adds a label given by router 2. This is what I'm trying to teach you today. How MPLS. How MPLS is what today's title. Router 2 is providing a label for the destination. That label is what router 1 uses while communicating to router 2. Likewise, router 3 has provided a label. So router 2 puts that label and send it to router 3. And router 3 has got a VPN to go to router 6. So router 6 has given a label, it puts that label. And then VPN is between router 4 and 5. So it puts 4's label and sends to VPN tunnel endpoint. Actually, VPN's gateway. So using 4, the packet goes to 4. And this router swaps label 4 with 5. That's the label given by. See, the 6 remains the same. The VPN is still there. Only the label, the top label gets changed as they jump from one hop to the other. The point that I want to make is when router 4 sends the packet, it will put the label given by 5. In order to speak to 5, it has to use the label given by 5. And when it comes out of the tunnel, the upper layer is removed, comes out of the tunnel. 6 knows that I have to use another label, swap it with 7. So it sends to 7. At last the packet reached. Here there are two things that we learn from this picture. Number one, my own label I can't use. I'll be using the label given by my neighbor. Only then, when my neighbor sees the label, he will know what it is. Correct? I have to carry the boarding pass given by the airliner. I cannot have my own designed boarding pass. I have to carry the boarding pass given by them so that when I show the boarding pass, they will understand who I am. Exam hall ticket. You may know Photoshop, you might have designed an IAS hall ticket, which is more attractive than what the exam company or the college gives you. But if you take your ID card, they are not going to understand who you are. You need to take your identity card, which is issued by the college. And when they see your identity card, they know who you are. They know very well that this is my student and he has got an exam today. So, we need to use the identity card issued by the college, not an identity card designed by us. Then who will use the ID card designed by you? Who will use the identity card designed by me? My college student, means my students. Assume I am also a student as well as a owner of a college. So all the labels that I design, my students will use it so that when I see the ID card, I'll understand he is my student. Likewise, when I am a student to my upstream device, I have to use the label given by my upstream. So this is the logic here. When you enable MPLS, we did it in the previous class. When you enable MPLS, labels are dynamically generated and assigned to every single network seen in the routing table of the router. After assigning the label, the protocol called LDP. What protocol? LDP, Label Distribution Protocol. The protocol called LDP, Label Distribution Protocol, generates an update packet, LDP updates, and it is sent to immediate neighbors. That neighbor may be physically connected, may be connected through a tunnel. Tunnel is also a virtual link, so anyone who is remotely connected through the tunnel will be seen as immediate neighbor. That is what happened here. You see, router 3 can see router 6 as a neighbor because there is a tunnel between router 3 and router 6. To use the tunnel, the upper layer has got label given by 4. So the packet will go from here to here. And 4 will remove and put label number 5. So that packet will go from here to here. And then 5 removes the label off and called PHP. We learn about PHP today. PHP was one word which I didn't like when I was in college days. But that PHP is different from this PHP. This is penultimate hop popping. When 5 is popped off and the label with 6 goes to router 6. So router 6 knows, this is my label. I know what it means. It means I have to push it to label to router 7 by putting label 7. Goes there. So what are the things that you learn here again? Labels are locally generated but not locally used, will be used by the neighbor. To distribute our label to the neighbor, LDP, Label Distribution Protocol, is used. In Cisco devices, when you enable MPLS, LDP will start working and doing these things that we spoke. We are not going to enable MPLS separately. MPLS gets enabled dynamically. Sorry, LDP gets enabled dynamically when we enable MPLS. LDP uses 646 port number, TCP 646. Initially, LDP will use UDP and it will send hello packets. Once the neighbor is discovered, you might have seen in the previous class, when I enable MPLS, the LDP neighbor was established, LDP neighbor discovered. You might have seen that. Once the neighbor is discovered, it will use TCP. So initially, to discover neighbor, it will do UDP and it will do multicasting. Once the neighbor is discovered, it's going to do TCP. Port number is 646. Easy to remember, no? 6 4 6 minus 2 is 4. 4 plus 2 is 6. 646, easy to remember. LDP 646. Okay, now let's move on to another picture and see what story it tells. I know this is a picture from Cisco. Here a packet is coming from source with the destination address. And there is no MPLS, so it is normal IP switched. Now MPLS starts. What MPLS does is it tags a label And that label will be what? That label will be given by this router actually. It tags that label and it is sending to router this MPLS. This will tag a label by removing the old label. See, this router removes the old label and puts the label given by C. We call it a swapping of label. Please understand. If this is B, this will be label B because it's a label given by B. And now this will be label C. And then this will be label D. So swapping of label, insertion of label happens here. Up to here, there is no MPLS. Insertion happens only on this router. Import is the word used. Or push is the word used. Push or import, both are same. Adding label, insertion of label. As the packet moves between B to C, what really happens is swapping of label happens. B is removed and label C is assigned. Likewise, here it is going to be popped off. Label will be popped off and it will go as a normal IV packet. I think this picture has got something more to say. Nothing. Now let's see this. So MPLS is running between router A and C. When router B receives a packet, for example, in order to go to this network 192.168.3.0, which is on this side, in order to go to this, the middle router has got local label as well as the outgoing label. In Cisco will be seen as local outgoing. And this is Juniper. They have ingress label, egress label. Ingress label is equal to local. This is the label that this router has generated and given to router A. And router A will put that label. See, 200 is advertised. Router A will put that label and send it to router B. And router B understands 200 means this network. I need to use the label given by C. C has given 100. So B will put that label 100 and send via this interface and the packet reaches here. And C will understand what the packet means because it comes with 100. 100 is what given as an ID to identify 192.168.0.3. So here we have seen how the labels are involved in moving the packet, switching the packet to the correct destination via correct path, via the path given by OSPF or EIGRP or BGP. You see, this is something we need to think. MPLS is not a label, sorry, MPLS is not a routing protocol, it's simply a label switching protocol. But now MPLS need to provide you the route which is already decided by OSPF with label path. Without MPLS, it is an IP path. Now MPLS should use that same IP path and provide a label path. That is why we call it as MP, multi-protocol BGP. So it can work along with routing protocol like OSPF, BGP, AIGRP, ISIS. It can work with all these routing protocols to provide you the best path as well as the label switch path. Multi-protocol label switching, MP. Now, we are going to learn what is PHP. Penultimate hop popping. Penultimate hop popping. PHP, penultimate hop popping. You know what is ultimate? What is ultimate? Final. Final. There is nothing more than that. That's the last. Ultimate. That is the meaning of ultimate. That's the final. That's the toppest. There's nothing more than that. Ultimate. So here we are asked to write down the last hop. Penultimate means what? Write down that this is the last hop. What do you have to write down? You need to write down saying, if it is the last hop, I'm going to pop. Pop what? Label. Pop the label. Remove the label. Simple. Let's take the picture in the above. This is not complete picture. Here for the beginners they are teaching they're teaching so they have done this, but actually when C sends the packet to D, it will not put this label. Why? D will say to C, I'm the ultimate router for you in MPLS. Is it not true? Correct. D will say, I'm the ultimate router. I'm the final router in MPLS. So, you need to know that I'm an ultimate router. So what this C will do, okay, you are an ultimate router, then I'm going to pop the label off. So C will pop the label and send as an IP packet only. Why? Let's say it goes with the label. This router D will receive the packet with the label. It will do the route label lookup first because it's coming with the label. It will do a label lookup. When it finds D, it knows what it means, but when it is checking for outgoing label, there is no outgoing label. You know why? Because we don't have MPLS here. No MPLS. So there won't be an outgoing label. Because there is no outgoing label, it will check the routing table now. And in the routing table, it says you need to go to this switch, a LAN, to reach the destination. So what you see here is there are two lookups. Number one, label lookup. Because the packet is coming with a label, router D is doing label lookup. After seeing label lookup, after doing label lookup, it understood that there is no outgoing label for this destination. So it will do again a route lookup to avoid this unnecessary lookup. See, it is doing two lookups. It can be avoided. Straight away, if D router will do IP lookup as the packet comes in, if it can straight away do the IP lookup, then it can go easily here. There is no need for MPLS lookup. That is why D router will advertise to C router with a special message, with a special label, a reserved label called 3. 3 is a reserved label for this purpose. When C router receives a packet with label number 3, it understands that D is the ultimate router. So when I send the packet to D for this destination alpha, I have to pop the label off. So packet will go without label. Let me erase it. It will go without label. As it is going without label, this router, even though it's an MPLS router, it receives a packet without a label. So it won't do MPLS lookup. It will only do the IP lookup, and it will find the path, deliver the packet here. So PHP is needed. If no PHP, then there will be two lookups, label lookup and the route lookup, which is not okay. See, it will work, but it is going to be an extra process. So by default, all Cisco devices will do PHP. In some vendors, PHP you have to enable a command, then only PHP will happen. So label number 3 is reserved for this purpose, to tell the upstream that I'm the ultimate router. So when you send it to me, don't put label, so that we can avoid two lookups. Now for label, I showed you there are 20-bit reservation, correct? The MPLS said how many bits you saw reserved for labels? 20 bit. 20 bit. This 20 bit is fully utilized except this first 15 bit. This first 15 bits you will not see given to any prefix. The first 15 label is for internal purpose. Say for example, I give you label number 3 is for PHP. Likewise, you have 1 to 15 reserved. And if you ask me what is the label number 12 means, I really don't know, because there is no necessary for us to know. Label number 1 to 15, they're internally used, and we are not going to use it. We have enough of label from 16 onwards to big number like more than 65,000. Then why I should go for label between 1 to 15? A very big number, a label can be a very big, you see, 2 to the power of 20. It's a very big number. These many labels are there. Why will I worry for that label between 1 to 15? Yeah, it's waste of time. So you will see labels assigned from 16 onwards, starting from 16 onwards. And these labels are dynamically assigned. See, you can also manually assign label, but think practically. If I have 10 network in our environment, on each router you need to assign 10 different labels. Are you going to do that? Just for 10 network you will not do it. For the real network, where thousands of routes are seen in the routing table, definitely we will not be ready to provide label manually. If you do it manually, there are chances of making mistake. So just allow MPLS to assign the label, which is going to be seen as soon as you enable MPLS. Labels will be immediately assigned by MPLS. No time taken, immediate. So don't try to give a label manually. That will cause a lot of problem. If you configure on one device, then you'll start configuring an all device, all network, sometimes conflicts, confusion. So do not configure manually, but there is an option to configure label manually. That's about the label. So PHP and label. Any question? Repeat again. Hmm. I'm not really understanding your question. So if no label, there is no security. Is that you mean? Uh-huh. We are using label for fast routing, for label switching. It takes time for us to read the layer 3 header, know the destination address, and then route the packet. Instead, we use a label, simple MPLS header, which is of 32 bit. You understand? Put your question in Tamil, please. லேபிள் யூஸ் பண்றது செக்யூரிட்டியா அப்படி கேக்குறீங்களா இல்ல செக்யூரிட்டிக்காக லேபிள் யூஸ் பண்றோமா என்ன கேள்வி அது Okay, the question is MPLS to provide security? No, MPLS is to provide fast routing. The MPLS VPN, if you see, we have not learned the MPLS VPN so far. If you enable MPLS VPN, it is just a VPN. It is not a safe VPN. It doesn't mean that MPLS is not safe. If you want the security, add IPsec to your traffic and do MPLS. So the question how I take is, we understood MPLS is faster. Is it safe to use MPLS? That's how I see Ramesh question. MPLS நல்ல வேகமா பண்ணுது, அதெல்லாம் சரிதான். ஆனா அதை பயன்படுத்துறதுல எதுவும் ஆபத்து இல்லையா? அது சேஃபா? அப்படிதான் அந்த கேள்வியை எடுத்துக்க வேண்டியதா இருக்குது. அப்படிதானே? Okay. So what I understood is correct only. Is it safe to use this fast protocol MPLS? Is it safe to, my question to you back is it safe to use an IP path in the internet? Your answer will be no. In the internet, no guarantee, no security. You're already using a path. I'm just making it faster. So don't ask security things to MPLS. MPLS job is not to provide security. MPLS job is, you are going in a slow path. You're going very slow, and MPLS says, come on, why are you going this slow? I'll make you faster so that you can reach the destination earlier. That's all the responsibility of MPLS. MPLS says, I'll make you faster. That's all. MPLS is not guaranteeing any security for you, because MPLS is not an IPsec. MPLS is not encryption. MPLS is not cryptography. So if IP path that you are using is safe, then MPLS is also safe. When you don't question IP path, don't question MPLS, because MPLS job is not to provide security. It is to just make the routing faster by providing labels. Right. Any other question? Yes. Hmm. Hmm. Very first time itself it will be fast right from the initial time. As soon as you enable MPLS, what happens? Labels are generated and shared with the neighbors. So my neighbor will put the label in the MPLS update, LDP update packet, and send it to me. Listen, as soon as MPLS is enabled on all the router, my neighbor will send the label for each network, saying for this network this is the label I'm using. For that network I am using label 40. For 200 network I am using label number 20. So it puts all the label and send it to me. Now I know what my neighbor use. Then if I want to send a packet to my neighbor for a particular destination, I put the label 20 because I want to go to the destination 200 network. So when I put label number 20 and send it to my upstream neighbor, my neighbor knows that I mean 200 network. So this all happens immediately. It's not like first time it will go normal IP packet and then check whether everything is fine and safe. Okay, MPLS is there. Let us try using MPLS next time. No, not like that. Not like that. Immediate. very clearly said. See, whatever Murli says is MPLS header is seen immediately after layer 2 header. You can also say MPLS header is seen just before layer 3 header. As a result, we avoid layer 3 lookup. Correct. Yes. Yep. I showed you yesterday the Ceph table. Ceph table usually will have what? Layer 3 information in a layer 2 level. Now we are seeing label attached to each Ceph entries. And that same label is what going to come from the neighbor's packet. When that label matches with the Ceph table, Ceph uses the label given by downstream and puts it and sent to the downstream. Yes, yes, Murli. Mm, mm, mm. See, no, you are not confusing. I am very clear with my thing. See, your question is MPLS is taking additional layer after layer 2 and before layer 3. There is an additional layer. Additional means overload, no. Won't that be more slower than before? That is what Murli's question. Correct, Murli? Hmm. You see, you went from India to America and you checked in with the baggage in Hyderabad. To your big baggage, they put you on tag on the bag, on small paper. Will that be too load for you? Will that be adding more weightage to your luggage? You are supposed to carry 30 kg. After putting the label, it is 35 kg. No, not even a gram. They put one label, and that duplicate copy of the label is given to you in the boarding pass behind your boarding pass. They stick it. Now, after reaching Los Angeles, in the belt, your box is coming, but same like your box. There is another box coming in the belt. Now, two boxes are identical. The other guy says, "This is my box." And you say, "No, no, 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 it's my box." Now, you're confused. There are two boxes. Only one box belongs to you. The other box belongs to the other person. Both look identical, same color, same size. Everything is same. Then what you do? You take your ticket, you flip it, and there is a label copy. You match this label copy with that label on the box, and you say, "Hey, listen, look at this. This is matching. So this box belongs to me, and that belongs to you." Because you had that label on the box, it has really saved your time. Otherwise, you need to call the airline in charge, the ground officer. "Sir, we have a problem. Please come." And he comes. And he will ask you, "Fine, describe what is there inside your box." You will say, "One pickle bottle, one set of medicine because in India it is cheaper. And I have this. And the other guy will say, "One box of cat meat, one box of cobra meat. Okay, let us open the box, both of us. So both of you will open the box. And when a cobra meat is seen inside a box, that belongs to him. When a pickle is seen inside a box, that belongs to you. See, it took a lot of time for you to do this. This is as equal as opening a layer 3 header, looking for pickle and cobra. If you have a label on top of the box, you no need to call an officer, the layer 3 engine, the routed engine. You no need to open the box, layer 3 header, all the fields of the layer 3 header. You see, definitely adding a label is not going to increase the weightage, increase the um, process utilization to process. Definitely it is lower, less in time taken as well as processing load. Yes, Murli. MPLS is used in all service provider network, all. MPLS won't be seen in the enterprises network. It is seen in all service provider network. Yes, please. Yes. You see, there are chances of having same label for a particular network on all the router. That won't conflict at all. See, you should not have same label for two different network on the same router. Again, repeating. We should not see same label on the same router for two different networks. That will conflict. Repeating again for some of you. Still you didn't get. You should not have same label on the same network, on the same router. Same label on the same router for two different networks. Same labels for two different network on same router. You should not have, and you will not have, because it is dynamically generating. Now when it generates, it will not generate the same label which is already generated. But the label that I generate and label that Girish generate may be same. So what? It's okay. Nothing wrong. I say A as in aeroplane. He says A as in apple. He says A as in apple. I say A as in aeroplane. So we use different label, different same label for two different network. Sometime I say A as in aeroplane. He also will say A as in aeroplane. So what? When I receive a packet as the A label, I understand it is for the destination aeroplane. And now I put A and send it to Girish, because Girish also means A aeroplane, same destination. So what? It's okay. It won't conflict. Even in the yesterday's lab, the labels were same on two different routers for the same network. It is okay because they are dynamically generated and assigned. Sometime you will see same labels generated by two or more routers for the same network. It will not conflict at all. It will not conflict. Only the problem if two different network on the same router gets same label, which will never happen only when you do manual configuration. If you manually configure labels, that mistake we may make it. That is why just leave it default. Let MPLS assign the label. Mm-hmm. No. For each network, we will say this will be my incoming label and this will be my outgoing label. So when I say this will be my incoming label, let's say I'm router B. I'm saying incoming label for 200 network is 30. So I need to now go to A router and say, hey, your outgoing label is 30 for 200. So A's outgoing is B's incoming. You need to plan all this thing. This is too much for you. For one network you will do. For how many 1,000 networks will you do this? No. So we have to define both incoming and outgoing on every router. First router's outgoing should be second router's incoming. Second router's outgoing label should be third router's incoming. And this you need to plan for every network with different numbers. Yes, Shivram. All right. So tomorrow we are going to have one more day of lab with the basic MPLS. And then following day we will get into advanced MPLS. So one more day of basic MPLS, meaning whatever we have learned today, we need to see it one more time, like PHP, how the labels are used to distributed by LDP, the hello packets, the neighbor discovery, all those things we'll learn practically in our tomorrow's demo session. Following that, we will learn how VRF can create multiple virtual routers inside a physical router, and how the VRF can work with BGP and MPLS to provide a layer 3 VPN. And we'll also learn things like route target, route distinguisher, and much more. Right? So thanks for joining today. Hope you enjoyed today's class. See you same time tomorrow. Thank you. See you. Bye bye. Thank you.